You've probably heard the term measure twice, cut once before. In this video, I'm going to talk about some of my favorite tools for designing a Java program, and it's important that we not skip this design step. A lot of times we want to jump in and write some code, but if we think about what we're doing ahead of time, we're going to save a lot of time in the end, and we're going to have a higher quality program that's easier to maintain. So 3 of my favorite tools. Number 1, Pseudocode. Number 2, flowchart. Number 3, UML using a tool called ArgoUML. So first of all, in a future video, you're going to see me write a program that is very similar to our very first programming assignment. So let me open up Notepad++, or any editing software will be fine, and let me just write a little pseudocode that's going to describe what this program does. So first of all, if you remember from the sample program I wrote before, the concept of blocks is very important. So we want to define our blocks. As is common in the Java programming language, we're going to have not just one file, but a series of files or a series of different classes that make up our program. To be honest, the more the better. We much prefer a large number of small classes over a small number of large classes. So I might start with one that's called begin class, and the pseudocode, the syntax doesn't really matter. We just want to think about what we're doing. So I can say maybe begin class driver, and then I'll say down here, give myself some space, and end class driver. Now I'm going to do another class. I'm going to say begin class vehicle, and then end class vehicle. Now note that these are both nouns, which is important. We don't want to confuse these two concepts. We don't want to mix them together. A driver can be separate from a vehicle, and typically is. So for driver, I'm going to tab in one, and I'm going to say method main. And again, the syntax doesn't matter as much. We just want to kind of think out loud, and then maybe end method main. Remember that the main method is that special method that starts our program. So after that, I'm going to say prompt user. Okay, and then I'll say end prompt user, maybe method prompt user. Okay. And so this is an opportunity where we're going to ask the user, okay, how many gallons of gas do you have? What's the mileage per gallon? And how far do you wish to go? Okay, but we have to get there. The only method that's going to execute automatically is this method called main. If we want to go from the method called main to the method called prompt user, we have to call prompt user. Okay, and that main method is typically very lightweight. Now, that's important. If you write a program and you find that you're writing the entire thing in the main method, I'll tell you you're doing it wrong. Make sure that that main method is very small and is only delegating work to other methods. Okay, so we enter the main method when we start the program, then we call prompt user, and then that gives us an opportunity to come into this prompt user method where we can do a little bit more work. Let me tidy things up just a little bit. Okay, so I might say create vehicle object. Okay, prompt user for miles per gallon, store MPG value in vehicle. Okay, prompt user for gallons of gas, store gallons of gas in vehicle. Okay, and then prompt user for distance traveled. Okay, and then we'll say invoke go method on vehicle. Okay, and then we'll say print status, or let's say state of vehicle. So those last few lines, when we prompt a user for different distance traveled and then we invoke the go method, we're going to do some math on the vehicle. We're going to take the distance traveled, divide it by the miles per gallon, and then subtract that number from the gallons of gas that are in the vehicle. And then when we print the state of the vehicle, we're going to say these are the gallons of gas that are left. Okay, so I'm going to need some things in vehicle then, aren't I? I might say, okay, we'll say maybe a number or a variable. We'll say an int, or let's say a double for gallons of gas. I might even put a comment up here that just says declare variables. Okay, so double gallons of gas. We could make an integer, which is a whole number, for miles per gallon. And we could add several other things there. We could say the type of engine, the type of transmission, but for our purposes, this will be enough. Then we'll make this start method go, and we'll say end method go. Or let's stay consistent. I don't think I put start before, so method go. Okay, and we're going to say parameter distance. Okay, then what I'll do here is say compute distance divided by mpg and store into gallons consumed. So gallons consumed might be a temporary variable or a local variable that's only known within this method. Then we might say subtract gallons of gas minus gallons consumed. And then we might say, okay, store, let's say subtract gallons of gas minus gallons consumed, store new gallons of gas value in gallons of gas variable. Okay, variable is a place where we store information. If you remember the binary calculator, we talked about different data types. Strings, which are text. Doubles, like I have up here, are what we call floating point. In other words, they can store a number that includes a decimal value, something like 10.5 or 2.3, something like that. An integer, by definition, is a whole number and cannot store anything off after the decimal. So a few different data types, just like we saw in that binary calculator video. Okay, so get new gallons of gas and gas variable. Now we might have a method, let's say method toString, and then end method toString. And this, maybe I'll put a comment up above this, and the comment's going to say return the current state of the vehicle. In the Java programming language, we typically use state to mean the value of the current variables. So we might say return gallons of gas. Okay, so you see up here in our driver class, we have print the state of vehicle. We could maybe say, before that, we could say invoke toString method. So you see, invoke the go method in vehicle, and I'll say pass the distance traveled as a parameter. Invoke the toString method, print the state of the vehicle. And you know what? We might want to go more than once. We might want to go somewhere more than once. So I could iterate over this. So I could say loop. Loop means I want to execute these terms more than once. And then we could say end loop. A loop is a block. And remember from the first program we wrote, every time we start a block, we want to indent by one tab because it's going to make the program more readable. So, listen, syntax not very important. We just want to think about the program we're going to write. We want to think about the order of statements. Thinking about it ahead of time is going to prevent us from getting sloppier. It's going to help us to not be as sloppy as we would be otherwise. Okay, now what I can do now that I have that in mind, I can make a flowchart. Visio is a nice flowcharting tool. It is Microsoft software, so it is commercial software. That being said, as a student, you usually get a Microsoft software for free or cheap. So let me just recenter this a little bit. This flowchart is going to be very simple. I'm going to say more shapes, and I'm going to say flowchart, and we'll just say basic flowchart shapes. These shapes are fairly well understood universally. So the little lozenge that you see here, that's usually a start and end. That usually marks our boundaries for starting and ending a program. So I'll say start. And then I'll grab another lozenge and we'll just kind of put it towards the bottom and we'll say end. Okay. And now what we'll do is we have a process. So I'll say something like prompt the user for gallons of gas. Okay. And then I might say, you know what, we need to create a vehicle first, don't we? So I'll say create vehicle. Okay. And then prompt the user for gallons of gas. We'll do it like so. Okay. And then I can take another one of these process boxes and say, let's try to line these up kind of neatly here. And I know it's kind of small, but we can zoom up once we're done. So prompt for distance traveled, okay? And then we'll say print the state of the vehicle. Now, you see that we just have the lozenge and then we have these rectangles. The rectangle represents a step that we're going to execute and then move to the next. But what if we want to make a decision? Remember I said we might prompt the user, hey, do you want to add another vehicle? In that case, we'll use the diamond and we'll say, sorry, not enter another vehicle rather, but make another trip. So we'll say, make another trip. Okay. If the user says no, then we're going to end because we're all done. So I'm going to bring that end lozenge up. I'm going to say insert in connector, and I'm going to drag the connector down to the end lozenge here. But I'm also going to add some text which says no, which means the outcome of this decision is no. We do not want to run again. Now, what if the outcome is yes? Well, then I'm going to use another one of these connectors, and I'm going to come up to the part where we say prompt for distance traveled. Let me click on that so we can add a label here that says yes. Okay, and you see if the user chooses yes, it's going to loop up. Now I can go ahead and zoom up now that we've put a lot of things on there. If the user chooses yes, then we're going to prompt for the distance traveled. We're going to run the go method and then print the state of the vehicle. As a matter of fact, you know what? I should add that step where we execute the go method on the vehicle. So let me just drag this down. Grab a new process here, and we're going to say execute go method pass distance traveled. Okay, and now what I'll do is I'm going to go back and add more connectors from line to line here like so we can kind of show an order in which we're doing this. Let me pin this. Actually, it's going to make life a little bit easier on me. And grab a connector again. And we'll simply connect each of these boxes together. There we go. Now, one thing, my connectors are missing arrowheads. They really should have arrowheads so we kind of see a direction that we're traveling in this program. So what I'm going to do then is I'm going to unclick the connector selector here, and I'm simply going to hold Control and select each of these lines that I've added. Okay. And I'm going to right click, and well, actually, no, I have it right over here. I have my format shape. If I didn't have that, I would click format shape right here. This gives me the menu on the right side, and I can say end arrow type, and we'll just do kind of a flat triangle like that. And now you can more easily see a sequence of steps we're going to take. Start, create the vehicle, prompt the user for gallons of gas, prompt for distance traveled, execute go method, pass distance traveled, print the state of the vehicle, and then make another trip. Takes us right back up to the top. If the user chooses no, then we go to end. So this is a simple flowchart. We cover a lot of these in more depth in programming logic and methods. So I'm assuming you've already taken that, or you have had some exposure to flowcharts before. So I won't get any more detailed than what we've done here, but that's very common in programming. Probably one of the easiest ways to show a very complicated process. Something I do quite a bit in my role, both my full-time job and at UC as a trainer. That's something I do a lot, is explain a complex process with a flowchart. One more tool that I like is one called ArgoUML. And to get to this is a free program written in Java. You just go to argouml.tigris.org. And there's a link you can click on. Give me just 1 second. I'll pull it up for you here. argouml.tigris.org. One thing I really like about this is that you can launch it from a browser. Click to launch the latest stable release. But this uses a technology called Java Web Start. And Java Web Start allows you to run a full Java program on your desktop, but launch it from the browser. And one nice thing it does is it automatically handles updates. So it will incrementally update the program if any parts of the program have updated. So a nice balance between a web-based program and also something that's really pointy-clicky and designed for a good user experience. So in our program, we're going to have two classes. One of them is called driver. And that driver, you see the class name goes on the top. The driver can have attributes or things that describe it. It can also have methods, or as we'll call them sometimes, operations. So I click on this plus here to add a new method, and then we have the method main. Remember, that's an important method. That's the one that starts our program. And then once again, I can add a new method just by clicking. And the new method is going to be called prompt user, which is called from main. Okay, that's about all we need for driver. Now we'll need one more of these classes. You see the class has 3 layers, and this other class is going to represent a car. So I drive here, or a vehicle as we're going to call it. I drive here and I say vehicle. Now why 3 boxes? First box for the title, last box for the method. The middle box is for any attributes that describe the class. So for vehicle, we have maybe miles per gallon. We'll shorten that to MPG, like so. And then we'll click again, and we'll say add new attribute. And this one we're going to call gallons of gas. So our program is deciding how many gallons of gas we'll have left after driving a certain distance. Now, for the methods, we know we're going to have a couple already. We're going to have one called go, and that's the most important one. We're also going to have one called toString. ToString, honestly, that one's a given sometimes. We'll say operation is like method. A lot of classes will have that, so you don't necessarily have to explicitly call it out. Okay, but doesn't hurt either. So go toString. We'll also have what's called getters and setters for the miles per gallon and gallon of gas. But there again, those are oftentimes a given, so we don't need to explicitly call each of those out. Go and toString is enough to get our idea across. Now, is driver a vehicle? No, they're 2 different concepts. Does a driver use a vehicle? Yes, a driver uses a vehicle. And so that's what we'll call a uses a relationship, which is typically a solid line between these 2 classes. Just indicates that a driver uses a vehicle. Now, what would be an alternative to a uses a relationship? An alternative to a uses a relationship is what's called an is a relationship. Is a Prius a vehicle? Yes, a Prius is a vehicle. It might operate differently from a normal vehicle in that pressing the accelerator might not change the gallons of gas. So what we're going to do in that case is we can extend vehicle using this little open arrow here, and we can make something called Prius, a class called Prius. So a Prius is a vehicle. It has some additional attributes that a vehicle doesn't have, like a battery that's used to run the car, and that battery might be measured in milliamp hours. Its charge might be measured in milliamp hours, so we'll say mAh. So you see a Prius gets what a vehicle has, plus any additional features that it has that a general vehicle does not have. And that's what we call an extends relationship or an is a relationship. A Prius is a vehicle. A driver uses a vehicle, a driver uses a Prius. Uses a, solid line, no arrow. Extends or is a relationship, a solid line with an open arrow pointing up to the more general type, or in other words, the parent type. So this ArgoUML diagram, we can save it in its kind of native form so we can go back and edit it. We can also do an export graphics, and we can export this just as a PNG, for instance. So I might say vehicle.png. If you're making a design document, that'd be really handy to take that little image and just plop it right into your design document, and that way the user doesn't need to have this Argo software either. So those are 3 of my favorite planning and designing tools for Java programs. In our next few videos, we're going to watch how to take this information now and make a program out of it. I look forward to seeing you then.